Hello, everyone. We are so happy to have you today. Today, we have an amazing presentation from Leslie Canavera, founder and CEO of PolArctic, who in just a moment is going to give a wonderful presentation for us here today. Leslie, if you would be so kind as to turn on your video and unmute yourself and tell the people who you are.
All right. Hello, everyone. I'm Leslie Canavera, again, the founder and CEO of PolArctic. I'm Yupik, Alaska native, and I was born and raised in Alaska. And because of my experience growing up in Alaska, I knew that founding PolArctic and the emerging technologies such as AI were going to be important for the Arctic. So a little bit about PolArctic. Our view is the Arctic is stuck between a rock and a hard place, or more specifically, an uncharted rock and sea ice. When working in the Arctic domain, climate change has become a real problem for maritime operations because of the challenges in forecasting and adjusting to the unprecedented rate of change. This is where artificial intelligence and machine learning tools provide a quick and cost-effective way to be able to plan and forecast in this dynamic environment. Our company, PolArctic, develops custom artificial intelligence machine learning tools for the Arctic based on the science of oceanography. We have 3 examples I'll be talking about later in the presentation: our sea ice forecasting, IceCube, coastal classification, and our nearshore bathymetry through wave inversion. With climate change, the Arctic has vast potential for new business development prospects, and other key economic leaders are actively working to capitalize on the opportunities these changes present. Sea ice is melting and has opened up previous non-existent shipping lanes and routes for tourism. Traditional modeling techniques are incapable of quickly and accurately adjusting to the unprecedented rate of change the Arctic is experiencing. To elaborate a little bit more on some of these challenges, the annual Arctic average temperature from 1971 to 2017 increased at 2.4 times the rate of the Northern Hemisphere average. Due to harsh environmental operating environment, machine damage and failure, such as running aground or an impact with icebergs, is the most frequent cause of incidents, accounting for almost half of all cases at 47%. There have been 522 incidents reported in the Arctic Circle waters over the past decade. As the number of ships in the region is expected to increase, so do the estimates of future incidents. Artificial intelligence is the solution to these challenges. PolArctic brings the power of artificial intelligence to the Arctic blue economy for responsible and sustainable development. Our services can support insurance, resource development, such as oil and minerals, shipping, tourism, and the fishing and aquaculture industries. Financial analysts at Guggenheim Partners estimated over $1 trillion worth of investments will be made to 900 planned Arctic infrastructure projects over the next 15 years. Technologies such as PolArctic, sea ice forecast, and nearshore bathymetry help businesses understand how climate change may impact operations, risk to people and property, infrastructure, supply chain, and scheduling and planning. Advancements in remote sensing and the frequency and volume of data collection are increasing exponentially. With artificial intelligence and machine learning, organizations can process gigabytes of data, generate actionable insights, and make informed business decisions. This will improve the safety, sustainability, and efficiency of operations in the Arctic. Here we have an example of our AI model called the IceCube. We have leveraged AI technology to develop sea ice forecasting tools that can work anywhere in the Arctic and can scale from a small inlet to Pan-Arctic. The image on the left is our ice evolution graphic. Each color represents a time frame for when the ice is frozen and provides a geographical reference for how the ice will freeze. The Sea Ice Prediction Network, or SIPN, is a group that solicits Pan-Arctic sea ice extent forecasts, and in 2019, our business contributed. It's hard to see in the image because we're the only AI model, but we're the little purple line. For the August report for 2019, we submitted an estimate of 4.3 million square kilometers for the average sea ice extent for September. The actual measured extent by the National Snow and Ice Data Center 6 weeks later was 4.32 million square kilometers. We were the second closest in actually estimating the average, beating out many supercomputers and NASA's model. This intertidal zone is one of the areas with the most active change, where coastal erosion is impacting operations and people the most. In Southern Alaska has large tides and mudflats, which are beaches made from glacial silt. We have built a new AI classifier that can identify the difference between a mudflat and very muddy water. This captures a unique feature in the Arctic that many other models don't capture or have the resolution necessary for safety of maritime operations. Our current work uses the science of oceanography to extract features that would otherwise be hidden, literally under the waves of the ocean. Using advanced remote sensing techniques from satellites, we detect waves and apply mathematical formulas that can infer the water depth from the wave pattern. We use these features as an input to an artificial intelligence algorithm and train us on a small part of the beach that has been mapped. Using this technique, we can reduce mapping time, and frequently monitor locations with high rates of coastal change. The economic benefits of having an up-to-date knowledge of the maritime environment can be considerable. Data on currents, tides, and underwater obstacles are important for maritime trade routes. For most ships, 30 centimeters of extra depth shown in a chart allows for 2,000 more tons of cargo to be carried. When looking at the possibility of operating in the Arctic for shipping, the accurate depth and dynamic environment even becomes more important, as there's no historical knowledge or experience in transiting the region. The National Science Foundation has funded PolArctic through the Small Business Innovative Research Grant to develop our artificial intelligence curated model architecture. When this is completed, it'll be capable of dynamically generating models to run complicated analysis. The goal of the system is the fusion of current scientific knowledge with data and machine learning architecture. Thanks for attending. If you have any questions, I look forward to answering them.
Thank you so much, Leslie. That was great. A big virtual round of applause for Leslie, everyone. What a great talk. Hope you all enjoyed it. Please make your way to the next session. Remember to take a one-on-one meeting in the networking section or browse the virtual booths. Have a good day.